If I draw any line at all, and I draw any other line at all, we should be able to tell if they're parallel or not. Now these are going to meet. They're not parallel. The key thing here is that they have different gradients. If they've got different gradients, they're going to meet eventually. But if I was to do a parallel line, they have the same gradients. Now it doesn't matter what gradient it started with there, it's always going to be the case. So for equation 1, we can quite simply see that the gradient is 3. Because y equals mx plus c is in this form here, where m is the gradient. Just to see why that is, when you're increasing x by 1 on our x-axis, as we're increasing, that means y is going to increase by 3. So every 1 we go across, we go up 3. And this is what gives us our gradients of 3. So now we just want to prove that the second line has a gradient of 3. And we know it has to be the case because it's saying show that they're parallel, not are they parallel. So I want to rearrange this into the form y equals mx plus c. So I'm going to keep the y terms on the left-hand side. I'm going to add 9x to both sides, and I'm going to subtract the 5 from both sides. And now I can divide both sides by 3. So we're always doing the opposite from y's perspective in order to get it on its own. We could divide by 3 first if we wanted to, but it's best to follow a backward BIDMAS approach when rearranging. So you're doing operations. You deal with your subtraction first. That was the minus 9x. Then we haven't got any more addition on this side, but we've got multiplication. We want to do the opposite of that. Opposite of multiplying by 3 is dividing by 3. Now I could have wanted to just put all of that over 3, but that's not really going to help us. We want to keep it in the form y equals mx plus c. So I'm going to break that up into dividing both of these terms by 3 individually. 9 divided by 3 is 3. And I could just leave that as 5 over 3. We're not actually concerned with one of this. That could be anything. What we're concerned about is this number here. And this also has a gradient of 3. And we've shown that by rearranging this equation. Now it's worth just making a statement that they are parallel and explain that both of the gradients are 3. Otherwise you haven't really properly answered the question. Because what is this showing? You haven't really explained what's going on here.